Hello and welcome in. Mark here, aka the Markster. This is video number 23 in the FreeCAD series. Today we'll be making this tetrahedron based die. By the way, to get it spinning like that, what I did was I switched from what I usually use, which is Blender, to the Open Inventor, and also edit menu preferences, display, enable animation needs to be checked. And then to do the animation, using the left mouse button, roll to the left and let it go, or to the right and let it go. Today I'm using FreeCAD. This is a pre-release 0.19 19694 on Windows 10. So this is, at this time, 0.19 is still in the development cycle. So let's go ahead and close this document. I'm going to go back to my default Blender mode, create a new document, and we'll create a spreadsheet. There'll only be one variable, which is going to be the circumradius. And we'll set up our alias, and I'm just going to use 100 as a start. Save our file. I'm going to call this one 023 tetrahedron die. Alright, so we're going to, from the part workbench, we're going to create a couple things here, a couple primitives. A point, let's create that one first, and also a regular polygon, which will have 3 sides. We'll leave it at 2 for the moment, and then we'll select a polygon and choose for the circumradius. We'll press the equals key here, ss.ss, select circumradius. So now we see our circumradius has been applied. Now we need to move the vertex up in the Z direction, and I believe I gave some bad information in an earlier video on how to make a tetrahedron. Through some experimentation, I've discovered that square root of 2 times the circumradius will give you the proper distance to move this vertex up in the Z direction so that we can loft to it. So we're going to press equal here, square root of 2 times regular, well, let's do circumradius out of the spreadsheet. So you can use mathematical expressions in here. See, square root of 2. We could have also used the sin, tan, cos, various trigonometric functions too in there. Alright, so now we have our vertex moved up in the z direction at the height that we need it at to create a tetrahedron with the loft tool. We'll select both of our objects, choose to create a solid, and now we have our tetrahedron. Let's go to the sketcher. I'm going to map to the vertices here, if I can get it to select. Three points define a plane. So that one is selected. Maybe. Hopefully it is. Let me hide this. Yeah, that's going to help. Now we select the three vertices, create a sketch, and it offers us 3 points on a plane as the mapping mode. This is reasonably safe. It's not any safer than mapping to a face, but I don't expect to be making any additional changes to that original polygon. It's always going to be a triangle, or to the loft object, so I don't expect to make any changes to this object. If I made the polygon a square, then it would totally ruin this. It wouldn't be a tetrahedron anymore. So I think we're pretty safe for the topological naming issue doing it this way. Could also map to the face instead. I'm going to create some links to external geometry using these points as well. And for point number 1, for face number 1, all we really need is a point in the center. So we can add our point, select the center in here, and apply the coincident constraint. So we're really done with sketch number 1 at this point. But I want to indicate to myself that I've already used this side, so don't get confused. We're not going to be doing anything with this sketch except using that point as a reference for a draft array, like we did with the die in the other video. So I'm just going to draw a circle on here. Regular mode circle. Then I'll know that this face has been used already. And I need to set the radius. I don't really need to. Okay, so that's going to let us know that this face has already been done. Could make it a little smaller. I didn't really need all 3 of these points. 1 was good enough for this one. Let's do side 2 now. So sketch will be side 1. Let's map this one just to the face. Let's see, no, that's not centered for us properly. So close this. I'm just going to delete it. And let's hide this sketch. Let's try these points. Let's see if this is going to center us better. Okay, that looks pretty good. Now what I want to do here is change this map reverse to true, and that way I won't be hidden. You saw how it was hidden a while ago? Set it to false and I'll show you again. We're kind of behind on the wrong side. We could use this tool, but then we'll lose the view of the loft object. So I'm just going to set the map reverse to true. And this is phase 2. So now you can see that we're centered. If we go to wireframe mode, you can better visualize that our origin is lined up. We're centered on that face. Alright. So let's go ahead and add our 2 dots to this one. The center dot was easy on the first face, but on this face it's a little bit trickier. This is the trickiest one of all. See if I can add my 3 dots again. Links to external geometry. And now I'm going to add another triangle. We'll center it here. Alright. And we'll set the bottom edge horizontal. And this radius, you know what I'm going to do? I'm going to add an edge here in construction mode from this point to this one. I want this circle to be the end circle, so it needs to be tangent to this edge using the tangent constraint. So now we can add a point here and a point to the center, and that'll be symmetrical for 2 points. Another option would be one here and one here. Another would be a point here and a point in the center. But I think I like having a point here and one in the middle on this edge. So let's add our 2 points. Put one here and one here for now. And we will constrain this one with the coincidence constraint. And that one, we'll just use the point to point symmetry to put it in the middle of these 2 points. And now side 2 is complete. We can see with the triangle that we've used that side already. And if we turn this one on, we can see we've used this side already. So now we need to use an unused side for side 3. See if I can catch these 3 points. Go ahead and hide. Don't really need to hide that sketch. Okay. Holding down Control while clicking. So I've caught those 3 points. We'll create a new sketch. 3 points on a plane. Some of the other options are available when you select 3 points. Alright. So this is side 3. Let's go ahead and add these 3 points again. Probably only really need 1 or 2. And construction mode edge on one side. And then the triangle. I don't think I caught that center. Did I? Let me apply that constraint again just in case. Yeah, looks like I caught it. Yeah, there are 2 degrees of freedom remaining. And when we set horizontal on this edge, that removes 1. And the other will be the radius of this circle, which we'll want to be the end circle. So we'll make it tangent to that edge. And this is side 3. So we need a point at each edge, each vertex on the inner triangle here. So put that one on there, this one on here, this one on here, and we're fully constrained. So that's side 3. Can't see what's, we don't have anything to look at on there, do we? Yeah, we do. We can see the triangle. Okay. And we've used that one, and we used that one. Probably should have put a triangle on there too instead, but this is the side that's unused. So let's select these 3 points. Uh-oh, I forgot to press Control. Do this one again. Create a new sketch. 3 points on the plane. Let's close and set this map mode to true this time. Reversed. And this will be the side with 4. Let's make sure we're lined up properly. Where are you? There you are. Yeah, looks like we're good. It just tilted at a different angle this time. That won't matter. So let's add our links to external geometry. And we could add an edge here instead of creating one construction mode, but because the loft tool was used to create this object, on some of the edges this would actually end up being a B-spline. I don't think on this one, because I think this is actually the edge where the polygon is located, but we'll use the construction mode edge here. I missed that one. I have to do it again. I'm just going to use block select and apply that constraint to both of the points. And now another triangle. Catch that center. Apply tangency. And we'll make this edge horizontal. And that's not good. That's not lined up right, is it? It's not lined up right. Let's see. Select this edge. Well, this is an opportunity to show something that I haven't shown yet. When you select an edge, if you can't get the constraint, of course you can go over here and get them. could select it here and delete it. But when you select the edge, there's a tool up here. Select the constraints associated with the selected elements. So because I have the edge selected, when I click here, it's going to select all the constraints that are associated with that edge. So you see it selected this one, and this one, which is not really helping me, is it? Because I really need that horizontal I want to remove. So just click on that and delete it from here. Let's see if we can rotate this. This is what we want, isn't it? Not this one. Not that. This would work. So we can make this edge vertical. Now we're cooking. Alright, and we'll add our points. We need 4 for this side. So we put 1 here at the origin and 1 at each vertex. And this sketch is complete. Alright, now we can go to part and add a sphere. A sphere will be used to create the little pips, I call it. So we add a sphere. And we'll set its radius to the circumradius divided by some number. Let's try 15. How's that going to look? Might be a little too big. Let's go now to the draft workbench. And here we can start creating our point arrays. So we select the sphere first, then this first sketch, the point array tool, and we'll have to open it to get to that sphere again to reuse it. Create another for that face. One for that one, and one for that one. You can adjust the radius of this sphere to some other ratio if you prefer. I think that'll do for now. And I can hide these sketches. And let's go to part. And I can use the shift key in the tree here to select all of these. So if you have a long list, select the first one, hold down the shift key, select the last one. Get them all selected. And then we'll make a union or a fusion. Now we might like to add some different colors to this. I showed you already how you can go to the View tab and change it. We can also right click, go to Appearance, and in here we have an option of different material types. I'm going to choose Shaded, and I'm going to choose, let's see what aluminum looks like. Does that look like aluminum to you? Let's go to the Fusion object, right click, Appearance, I choose Shaded, and maybe emerald. What's that? Well, that looks nice. We'll have some emeralds in there. Alright, and now select first the base object, then the cutting tool, which is the fusion of the point arrays, and do the Boolean cut. And our tetrahedron based die is complete. If you don't like the looks of this, you can experiment with different placements. I never did look up an image of these to see. I assume they have them out there online to see pictures of how the points are laid out. And of course it's going to be parametric. Now when we change this figure, it's probably going to mess up the colors. Let's try 50 to see if we're parametric. Yeah, it did mess up the colors. So you'd have to go in and do the colors again. And that can be accomplished. We'll delete that cut. The fusion lost its color for some reason. Appearance here. Change it back now. Try gold this time. What's that gonna look like? Alright, and loft is the base, fusion is the tool. Redo the cut. I think I prefer emeralds over gold. Okay, well that's gonna do it for today. Thank you for watching, and as always, have a great day.